Exponential models are real-life situations that can be modeled using exponential functions. Exponential functions look like this. Y equals a number, right? This is the initial value times a growth or decay rate to the power of x, okay? Now notice what's notable about exponential models is that the x is in the exponent, okay? Now, these exponential equations, they can be used to model situations where quantity grows or decays by a given percent. For example, the population in a city can grow by 10% each year. A car can lose 6% of its value each year, and a savings account can earn 3% interest each year. When working with situations that describe a percent change, you have to determine the rate of growth or decay. So let's say something is decreasing. Something is going down by a certain percentage, like a car losing 6% of its value each year. This is called a decay rate. And we take that, our starting point is 100%. We subtract, what's that decrease? So like, for example, in this case, it would be 6. Okay, so for example, let's just use 6 as an example. Okay, I would get 94%. Now, when I divide this by 100, what that does is it moves this decimal place over. 94 divided by 100, you can put this in your calculator and try it out. 94 divided by 100 is 0.94. That would be the decay rate. Now, if something is increasing, for example, an account is earning 3% interest each year, that's called a growth rate. And what that looks like is I would take my 100% and I would add my growth rate. So that would be 103%. And once again, I'm dividing by 100, which moves the decimal place over 2 spaces. This would be 1.03, and that is what's called my growth rate. Here's 2 more examples, and then you're going to get a chance to try. The population of a city is growing at a rate of 5% per year. So I'm always going to start with 100%. So I can just write that right off the bat. And now I have to decide, am I adding 5% each year or am I subtracting 5% each year? So I can see the word growing. So I know, oh, this is adding 5% each year. So that's 105%. And then when I divide by 100, right, you can put in your calculator 105 divided by 100 if you need help with this. It's 1.05. The other way to do it is just to say, I'm moving the decimal place over. That's the same thing. Dividing by 100 and moving the decimal place, it's the same outcome. The number of bacteria in a sample decrease, I see this word decrease and I think, oh, it's getting smaller, by 10% every hour. So I'm going to again start at 100%. I'm decreasing by 10%. So this time I'm subtracting 10%. So I get 90%. I'm going to divide that by 100. Right? Or I can just move this and I get 0.9. Now I could write 0.90, but that second 0 is unnecessary. Okay? You're going to get a chance to try this right now.